We're going to go ahead and get started here. This is Keith Weber. I'm the GIS Director at Idaho State University, and I'd like to welcome you to our webinar on the NASA RECOVER Decision Support System. Thank you very much for taking the time out of your schedules to join us and to learn more about the NASA RECOVER project. Today's schedule, what we're going to do, this I believe I sent to everyone with that invitation as well. We're at right now at 11 a.m. Mountain Time, and we are right on schedule. We're doing our welcome and introductions type of things. In just a couple of minutes, we're going to run through a PowerPoint presentation, just talking briefly about the what is RECOVER type of thing, just a conceptual, let's call it a 30,000 foot overview of RECOVER. And then we're going to zoom down in, running with that same analogy, doing a live demonstration of the RECOVER self-service or self-serve generator. I'll then open the floor for questions. I'll answer those questions, and then we'll go back into a second demonstration, a little bit more PowerPoint, second demonstration of the RECOVER Decision Support web map, the end product of the generator itself. Have another question and answer session, and we should be ending this right at noon. Now again, if you have any additional questions following the webinar, or if you have to jump off the webinar before it's completely finished, you can certainly send those questions to my address directly. It looks like webkeet@isu.edu. You're seeing that right up on the screen. You can make note of that, and I will make sure that I get your questions answered. We're also recording this presentation and this webinar, and so what I'll be doing is later this week I will be posting this video to YouTube, our YouTube channel. I'll send the link out to all folks who have been registered for it. You'll be able to watch it again as much as you wish. Plus, we'll be sending out some additional documents, step-by-step tutorials, if you want to call it that, on how to use the self-service generator and how to use the web map itself. So a couple of those things to help you out as you begin gearing up to use RECOVER in the 2016 fire season. Now, so far, our spring has been nice and wet over here in southeast Idaho. What that means right now, and I've been looking at this and watching it, is the cheatgrass is getting really tall. It's very green right now, but it's getting very tall at the same time. We've got stuff 12 inches, 14-inch tall cheatgrass, which for right around here, southeast Idaho, that's some real big stuff. So if that stuff dries out significantly and quickly, we could be in for a bad fire season. Who knows? We're not hoping for a terrible fire season. We're hoping for smooth sailing. But across the western United States, it's pretty much inevitable that there will be some wildfires. We'd like to have RECOVER there ready for you to use to support your wildfire decisions that you need to make, post-fire planning, those sorts of things. So we'll jump right in and start talking about NASA RECOVER Wildfire Decision Support System. My name again is Keith Weber. I'm the GIS Director here at Idaho State University. I'm the Principal Investigator on the RECOVER project. I have a couple of other folks I think are on the webinar on the line right now with me that are co-investigators of this project from NASA Goddard Space Flight Center. That's John Shanasi and Mark Carroll. We also have Maggie Wooten and Roger Gill at Goddard Space Flight Center as well. Here at the GIS Center at Idaho State University, there is Jeff May, who's in the room with me, Ryan Howerton, Kendra Sear, and some new students who have just started working with me in the summer. We have Cody Feldman, and Brian Nicholson is also part of the RECOVER team. They're all here in the room, and we'll be able to answer any questions that you might have. So let's start with what is RECOVER. RECOVER actually is an acronym that comes from Rehabilitation Capability Convergence for Ecosystem Recovery. It is a NASA Applied Sciences program sponsored project. Perhaps more specifically to your needs, to the end user's needs, what is RECOVER? Well, it's a customer-driven and customer-centric decision support system. Okay, so we're going to talk now about the benefits of RECOVER, and what I specifically want to draw folks' attention to is the this one right here, cross-organizational collaboration. That's one thing that RECOVER is very, very good at. If you can think about probably any wildfire that you've dealt with in the past, even things as small as maybe 500 acres, most of those are going to be multi-jurisdictional. You may have some portion of the fire that, let's say, burns on BLM land, another portion on state lands, maybe another portion still on private lands. Trying to coordinate amongst all those different jurisdictions and organizations is greatly enabled and enhanced by using something like RECOVER, because it's leveraging what we're calling a web-centric or web GIS type of platform. All that you need to use RECOVER, the web map, and even the generator, the only thing you need is an internet connection and a browser. If you want to do more sophisticated analysis with the data from RECOVER, of course, then you'll need software like ArcGIS or something similar to that. So how does it work? Let's say, step one, we have an ignition. And this is like preaching to the choir. Many the wildfires start by lightning strikes. So we have an ignition, and then that moves us to step two. We are going to then generate the RECOVER web map. So I'm going to go ahead and click on this. Okay. Launching the web map generator. See this splash screen that comes up. I'm simply going to click proceed. And the first thing I'm going to do here, it's just two steps. Step one and step two is I'm going to load a local shapefile. Now this is a shapefile of a fire that I'm concerned with, let's say. So it's a shapefile that I have zipped up and I put it on my desktop. So I'm clicking on this, and this little application, the generator, is reading this file and displaying it on my screen, zooming up to it so I can see it. The second step here, we're now done with step one. The second step here is I need to give this fire a name. I'm simply going to call this the webinar fire. Tell it that this is in Idaho. Well, most of it's in Idaho. A little bit of it you can see is burned into Oregon, but I'll call it an Idaho fire. And now I'm going to do an upload of the file, the same file. And this one actually sends it to my server, to the RECOVER server. If you do not have a fire perimeter, you can simply zoom up to the area, and then what's very important here is to draw some sort of area of interest. So I'm going to grab this area here, release this. Now I'm done with that part, and I'm going to scroll down a little bit. There are 25 layers you can choose to include, and all of them are included by default. You can choose to exclude some if you want to. I'm going to leave all of them on, and then I'm going to send this, put in my email address so that once the web map has been created, I will get an email at this address that gives me a lot more information about RECOVER and a link to the web map that's been produced for me. If I want to, I can request additional data sets, fire-affected vegetation, that's a differenced NBR. I can request a debris flow model. We don't produce those in-house. Those are actually produced by colleagues at the University of Arkansas and Michigan Tech University. Or I can also request a pre-fire vegetation monitoring. And we'll talk more about those products later on. So once I'm happy with this entire thing, I can then click the Submit button. And you see this little wheel spinning, this little graphic, means that the RECOVER server is working on this. And in about 5 minutes, maybe 6 minutes, we will get an email at this address telling us that the whole process is complete. And I'll tell you what's happening. Okay, the RECOVER server is clipping. Now we have 25 base layers that are being used. They're both raster and vector. It's being clipped to that AOI polygon, area of interest. And that is that rectangle, the big square or rectangle that I drew around the fire perimeter. It's then assembling all those layers into a map service with uniform symbology, color maps, and naming conventions. Where does all this stuff come from? Well, it comes from authoritative sources. A lot of the data we get from the BLM, NRCS, RSAC, Forest Service, GeoMac, USGS, and a tremendous amount of data directly from NASA, the MODIS imagery, Landsat imagery, and those sorts of things. Another thing that's happening all at the same time is that there are some fire-specific reports that are being created for you. So RECOVER covers the western United States. This colored area here is the area where we have all that data. Those 25 base layers are wall-to-wall for this western United States study area. We're using Esri's ArcGIS 10.3.1 right now. We'll be upgrading to 10.4, which is the most current version for those of you who know GIS or doing GIS stuff. We're serving or storing all of our data in a file geodatabase. Again, it's vector as well as raster data, and of course we're leveraging automated Python-based map services. There we go, processing complete. I'm going to go ahead and click OK. At this point I can close up this generator, and then I'm going to go to my email, and I will have an email waiting there for me with a link to the map that I just created. I will pause right there and ask if there's any questions on the RECOVER generator, how you might use that.
In order to use the RECOVER, did you say that you need to input the fire boundaries to begin with, or is that information included in RECOVER?
Yeah, so what you'll do, so the question was, do you need to input the fire boundaries? So the RECOVER generator will need, you will need a fire perimeter to make that work. So if you have that fire perimeter, then you simply zip that up take that shapefile, zip it up. I always store it on my desktop, and then you click on that step 1, the step 2, and you simply load it that way into the generator. So I'm wondering,
It's not required. They can just use an AOI if they don't have a perimeter ready.
Yeah, that's right. Jeff May, who's sitting here with me, also said that if you do not yet have a perimeter, it's not like you can't use RECOVER, you can't use the generator. If you just know that there's a fire happening in this area, wherever that is, you can zoom up anywhere on that map, draw your rectangle out there, give it a fire name, put your email in, click submit, and it will go. Does that answer your question about the using the generator?
Yes, it does. And the information about if you don't have the boundaries, you can just kind of input a guesstimate to the area was also helpful. Thank you.
Yep, you can do that. Yes, definitely. And if you then come back at a later time, let's say the next day, and now you have a perimeter, you can simply go right back to the generator, and then input that perimeter shapefile perimeter, draw up maybe a different AOI, but if you give it the same name, that's really good. Just give it the same name, let it run again, it will overwrite everything. And that way, if you've already delivered the web map decision support system, that URL, if you've already delivered that to other people in your agency, or other people in another agency that you're working with, you don't have to send them another email that says, oh, now the web map's URL changed, we updated it. Nope, just give it the exact same name, and from that point on, everyone's using that URL, and it'll refresh and refresh and refresh as much as you need it to, and it works out really, really well that way and avoids confusion. Other questions?
Hey Keith, this is Craig Thompson.
Uh-huh.
Now with the fire perimeters that are zipped up, do they need to be in a certain coordinate system, or is it just reconfigure on the fly? Does it reproject?
Service handles that.
So the question was, the fire perimeters that are uploaded, those shape files that are uploaded, do they have to be in a given projection? The answer is no, they do not need to be in a given projection. They need to have a projection defined for them. So what happens is, one of the first things that the automator is doing, the generator is doing, is it's looking at that shapefile, and it's looking for the PRJ file, which is the projection definition file, and that tells it that maybe it's in latitude, longitude. Okay, you can figure that out. It will ultimately project everything into the Albert's equal area USGS version, and that's how all your data will be delivered to you. Does that make sense?
Sure does, thanks.
Super. Any other questions folks might have? Okay, great. Those were very good questions. We'll go ahead and continue on. Okay, so step 3 is check your email. This is an email that I generated. I've been experimenting with this for a while. This was from January as we were working on the generator. I got an email, and you'll get an email from this address, Recover Decision Support System, or recoverdss@gmail.com. And in that, you're going to have a URL. You'll have a couple of other additional URLs which are links to help files. All you need to do is click that link, and your web browser will launch it. And this is what you're going to get.
Are we going to need to send that to everyone?
Okay, so this launches up. Well, this was going to be our webinar fire. That's the name I was giving it, but I ran it before with its true name. And this, what you're looking at right here, is the Recover Decision Support System web map. I'd like to take just a minute or so to go through the graphical user interface. It probably looks awful similar to what you might be accustomed to with using Bing Maps or Google Maps, those sort of things. You have a basic navigator over here using your pan and zoom tools. You have some additional tools available to you right here. Everything from your layer list, which is already open for you by default, to an identify tool, which we'll look at here in just a little bit. Some nice visualization tools called Swipe and Spotlight. Graphical tools, bookmarks, so if you want to, on your own system, come back to certain bookmarked areas, spatial bookmarks. Import tools. If you have more data on your machine, on your computer for this fire, you can do the exact same thing we did with generator. Zip that thing up and open it up on your own system. Now that won't be visible to everyone on the internet. It'll be visible to you on your own desktop. And we have these printing capabilities. So we've already received some print templates from the BLM. We have a GIS Center print template that I'll show you that here in just a little bit. If other agencies or organizations have print templates that they'd like to have become part of Recover, simply send those to us. I can give you better instructions on how to do that, and they will be incorporated into RECOVER as well. Over here, again, just real quick on the graphical user interface, we have the menu. You click it, it drops out. There's our reports. You can download this data as a zip file. All the data you're going to look at here is going to be available to you. And then go to some websites, the RECOVER web page, Goddard Space Flight Center, contact us for additional questions, whatever. Okay, so I'm going to come back here now. I'm going to roll up my menu, close that up again, and we're going to look at the layers that are available to us. You'll see on the very top here we have 3 real-time links. One is called real-time fire severity. Now these are observations in the field. So if you are using Collector for ArcGIS, we have a RECOVER real-time map app that you can use that's associated very closely with the RECOVER web map, and all records are streaming in to these web maps automatically. So if there were fire severity observations made by, let's say, BLM or Forest Service people out in the field, those things would show up. All you got to do is turn them on. Similarly, we have these real-time field records, very common things from aerial hazards to fence cuts to heat sources, you name it. Tremendous amount of information that can be recorded during a fire or of course after a fire as well. And then we have a third real-time, these are called fire line information, aerial hazard line information, dozer lines, heat lines, etc., etc. Lots of stuff. And again, just turning those things on, if things have been recorded in the field, you will automatically see these things. And the refresh is about every 30 seconds, and if it's not fast enough, of course, you can always manually refresh the map. Then we get into these 25 RECOVER base layers. By default, the only thing that is turned on is the fire boundary, but we might be interested in turning on some additional things here. There we go. That's what I was expecting. And what I'm doing is I'm displaying the soils from the Surgo layer, and I'm going to tell the RECOVER decision support system that I want to find out a little bit more about these Surgo soils. So I selected Identify from Surgo Soils, or Soil Surgo, and it immediately highlights that area for me, and it gives me this little link. And I'm going to click on this thing, and that launches one of the reports that's available. We have hundreds and hundreds of these things. This is Ecological Site, Plant Association, and this tells us that that specific thing I just clicked on is from, map symbol and soil name, map symbol 1, acre lane, rock outcrop. There's 2 different things here. Loamy soil. We have understory of blue bunch wheatgrass, and you can see all this stuff, basin, big sagebrush. So we have reports that we've pre-generated for you for hundreds and hundreds of those soil polygons across the western United States. Another capability that you'll see is, maybe you want to look at a couple of different layers here simultaneously. So here is the fire-affected vegetation layer, and maybe I want to look through it and see something else beneath it. Maybe I want to look at take a look at slopes. This right over here, see these little arrows just to the right of the title of the layer itself? If you click on it, we can tell it to zoom to it, or I want to change its transparency. And I can make, notice what's happening, the fire affected vegetation 50% transparent. Now I'm looking through it, and I'm seeing the base layer beneath it, which was in this case the slope. And this helps you, of course, visualize the interaction between fire-affected vegetation and the slopes of those lands. And you could have many, many different things turned on. You can change the draw order of these things if you want to. We can move this one up so it's drawing over the top. We can move it back down, and so on and so forth. Lots of different capabilities to help you visualize all that different data, which of course will help you start getting a feel for what's happening with that fire, what has happened with that fire, and maybe get some questions going in your mind, get some pre-planning going on how you want to deal with this fire and how you're going to rehabilitate it following the containment of that fire. Some of the other reports that you have available. This is the summary report that we're looking at right here. Just breaks down that fire perimeter, everything inside the fire perimeter by the jurisdiction, BLM lands, Bureau of Rec, private lands, and so on. And then it breaks it down even further. It takes all the BLM lands, breaks it down by the soil. In this case, Idaho 665 is the region, and then individual map unit symbols. And you might see certain areas are of concern. That one that we looked at a little bit ago, that number 1, remember that number 1 that we clicked on? That one is in total almost 6,000 acres. So 6,000 acres of stuff that was blue bunch wheatgrass, big sagebrush have been affected by this fire. I'm going to close this up. As I mentioned earlier, you can do a data download. Click that button right there, and immediately the Recover service is zipping up your fire and all that stuff that you asked for. You can see that perimeter here. All that whole AOI that you asked for, all that stuff is zipped up for you. It's in a geodatabase as well as raster data files, which are all in GeoTIFF format. It's all in the same projection. You can grab that. Maybe if you're not a GISer yourself, you can give it to a GIS specialist in your office, ask some more advanced questions on it. And the wonderful thing, of course, is that you're all using the same data. Decisions are very reproducible when you're doing something like that. And I mentioned that we'd talk about the print capabilities. So if I come over here and I give this thing a name, I'm going to say this is my fire map. Put in my name. And here's my different layout templates. We can do it more or less just like a screen capture with this map only. Use a GIS Training and Research Center default template. Maybe I want to use BLM landscape form template. You can ask for a different file format, maybe, and I suspect this will be pretty popular. You're going to want maybe a PDF of this thing. And then we tell it to print. Now, one thing I'll note to you is that this process, Chrome and a lot of other browsers are going to think it's a pop-up that's going to happen, and you may see this right up here, pop-up blocked. Okay? Simple fix is tell it to always allow pop-ups. Done. Now I'm going to tell it to print it one more time. I had to force it to give me that error, and I wanted you to see that. That's a browser error that is likely going to come up, but it's an easy fix. There you go. Now that's your PDF that was just generated for you on the fly. Now you may not think too much of it. I was just very quickly putting some stuff together, but you can set this up exactly as you want it. Zoom in, zoom out, put on the layers that you want, generate this this PDF. If you want to keep this for the future, just like any PDF, just download it. It's now on your machine. You got it. If you want to make changes to it, that's okay. Close it up, make some more changes to it. Maybe you want to change the base map. Have the base map change from aerial imagery to the topo map behind it. Lots of those sort of capabilities to help you make the best use or the most use out of Recover. I'm going to now go back to our PowerPoint and moving on to the next PowerPoint, talk a little bit about additional data requests. I mentioned this a little bit earlier. You can request fire-affected vegetation. That fire map that I was just showing you included a fire-affected vegetation layer, and that's exactly as it'll be delivered to you, just as a scale of colors, but still communicates a lot of that stuff to you. Hopefully, folks can make use of the collector real-time application to do field observations of unburned, high, medium, and low that can then help your agency create an updated fire severity. Actually, make your own fire severity layer for your management purposes. You can also request a debris flow probability or susceptibility layer and an NDVI vegetation anomaly for your fire area. But this one is based on MODIS satellite imagery and the 16-day NDVI composite imagery. And what it's doing is it's calculating the long-term average. So 2001 through, let's say, December 31st, 2015. That's where the long-term average comes from. Then what it's doing is it's looking at the current fire season, January 1st, let's say, through today. Say May, I don't know if this when the most recent shot of this 16-day composite was, but let's say it was just yesterday, May 23rd. That then is being used as the current fire season. And if you make that request, you can request that using that generator that we looked at just a little bit ago, or simply by contacting the GIS Center at a later time through either of those two emails that you see on that NDVI anomaly slide. What do you get? Well, you get a map layer that can be opened up in ArcMap, and you get some charts. Now, this is the first chart that you will probably look at. These charts are saved in PDF format for you. This one shows March through September. So when we run that NDVI anomaly, you don't have to run it, or you don't have to have us run it from January through December. You can say, no, I'm only interested in the growing season or a certain part of the growing season. So let's say, in this case, I chose March 1st through September 30th. And this was a past fire. We ran this in 2015. And this is the, what you're looking at here is the flat line right at 0. Just it reminds you that that right there means that there's no photosynthetic activity. So if you've got some features in your study area, in your map, so this is only clipping out your fire area, that rectangle right around by your fire area, and just looking at it. If you have nothing happening, maybe you have a bunch of roads or something like that, then you may have some pixels or whatever that average it out down close to the no photosynthetic activity. The vertical line that you're seeing in yellow is the start date of your fire. So that's when that fire actually happened. So you're going to say that the fire happened on a certain date. That's part of how we run the anomaly for you. Then the two, I think, maybe more exciting lines that we're looking at, we're seeing the long-term average in that blue dashed line. The year that we're currently looking at, in this case, like I said, we were running it for 2015, is shown in the red line. And what we're seeing here, if we kind of analyze this, is that prior to the fire, so everything to the left of the yellow line, we had a lot of stuff happening in 2015 that was above the long-term average, meaning we had more photosynthetic activity, which then translates into more vegetation on the ground. For fire people, more fuel. Okay, more fuel is on the ground. The second chart that you receive is looking at that same exact information, but it's just assessing the difference of the average and the departure from average. I have a typo in here. It says, this is an older version, it says departure from anomaly, and it should say departure from average. Okay, so as I already picked up on this first chart, the second chart shows it even more explicitly. We have some pretty high differences. Early in the growing season, probably lots of rain. Early in the growing season, looking at Julian dates 31, 61, and that's what we're seeing is it's very high, but then it looks like it dried out, and then the fire happens. So lots of vegetation on the ground prior to the fire, and then that fire occurred when that vegetation had senesced. And following a fire in the fire area, you'd expect it to drop below your average because you've just consumed all that veg. Okay, so I'd like to open the floor once again for questions regarding the decision support system, web map that we looked at, or any of the other things that we talked about in this part of the presentation, or even earlier than that.
Hi, this is Jamie Labor from the National Weather Service. Regarding the debris flow probability, I missed who you said was doing that for you, like someone in Arkansas or something?
Yeah,
that just...
Yep, the question was regarding the debris flow probability. The folks that we work with very closely are from Michigan Tech University and University of Arkansas. And we also have worked in the past with Mary Ellen Miller from Michigan, as well as Jason Keene from the USGS.
Okay, thanks. Because I'm from the Los Angeles office, and I've worked really closely with, in the past it was Sue Cannon, and then when she retired now it's Dennis Daly and Jason Keene. Yep. So I'm glad to hear that Jason from the USGS and that office is involved too. Yeah,
right. So there's I guess options for you. I know that Jason Keene is also involved with the debris flow project that is being done, as I said, from University of Arkansas and Michigan Tech. Other questions that folks may have?
This is Catherine from the Weather Service in Spokane, and I'm wondering, so when we make a request, you know, for most of, well, not most of us, for some of us, the biggest deal is the, you know, the vegetation change. Mm-hmm. So how long do you have to wait for that? And do you keep us updated on satellite passes and things like that?
Right. So for that NDVI, what we're calling the NDVI anomaly product, when you make that request, typically we don't run the anomaly analysis until the fire is contained. And it literally takes us about 2 minutes. We run it on one of our large, any of our large research workstations, and in about 2 minutes it will complete that analysis, and we then zip up the package and send it over to you, and you're in business. We can also actually put that data out on the server so that when a person clicks on the data download button, they receive it as well. So that's the I hope that answers your question regarding getting the vegetation change data.
Well, I guess I'm thinking, you know, using the BarkMac products from the RSAC in the past, you know, they were waiting, you know, you had to wait for 7 days for such and such satellite to go over, and if that wasn't a good pass, you had to keep waiting. So,
right.
Like you're using different data sources?
Okay, yeah, so the to do the fire-affected vegetation, DNBR, that we run, we're in the same situation as RSAC or anyone else would be in. We're relying on Landsat 8, which has an overpass of 16 days. Now we're also experimenting with the European Sentinel-2 satellite that has an overpass of 8 days. So what we'd like to be able to do is to use either one of those two satellites, whichever one allows us to deliver the DNBR product faster is what we would do for those users. We know very, very clearly that time is of the essence to take a look at what did that fire really do to my ecosystem. In some cases, you luck out and you get the imagery right away. In other cases, we've seen this happen where several days after the fire, you have a Landsat overpass, but it's still smoky or it's cloudy, and so you wait for another 16 days, and you wait for another 16 days, and it just is really difficult that way. But I think that now that we still have Landsat 8, and then we also have Sentinel available to us. RSAC would be the same way. They'd have this data available to them. I think that we're going to see better response in generating those fire-affected vegetation layers, whether we do it or Forest Service or USGS does it.
Thank you.
Now, Karen Kraus had a question that she emailed in, and that was how to locate the menu.
Right, because we use the Recover 2 app. That was before the data
Yep.
download, so they won't see it in that one. But if they
Yeah, so the link from the PowerPoint that goes to that fire, that's a current fire map. And if I go back to that thing, and that's what I'm running here. This is Recover giscenter.isu.edu. This is the soda fire that we're looking at. And you'll see these 3 bars. I found out from one of my programmers that the programmer world calls this a hamburger. I think that's cool because I like hamburgers, I guess, But you just click it, and that's your menu. The menu is always going to be in the upper right corner. So I hope, Karen, that answers your question as well. And this is the graphical user interface format that you're going to see for 2016 wildfires. Okay, are there any other questions that folks may have? Okay, well, thank you very much, folks, for joining in. If you want to make use of Recover, we're going to have secure passwords over the top of both the generator and the Recover Decision Support System web maps that are produced in 2016. So you'll need to get a username and password from us. Just email me, either at that WeBeKeat email I showed earlier, or any of those email addresses that are in the PowerPoint, and request a username password, and we'll get you all set up and ready to go to deal with the wildfires in 2016. Thank you very much.